Okay, so malapit na tayong matapos sa chapter na ito. So ang discuss natin ngayong araw ay chaos at saka hysteresis. Okay, gandang kombinasyon, di ba? So, tawag dito, na-introduce ko yung concept ng hysteresis before sa mga earlier lessons. Okay, basically, lilitaw siya dun sa pag meron kang tawag dito, yung amplitude na dependent sa isang sa frequency ng oscillation. Okay. Okay. So, before pinag-usapan natin itong tawag dito, differential equation na ito, f not cosine omega t. Okay. And sinabi natin na yung isang possible solution ay a omega cosine omega t minus saka yung phase ay actually, if that is the case, then yung tawag dito, then yung behavior ng amplitude at saka nung phase angle ay hysteretic. Okay. So, yung amplitude na yan is given by f naught over k minus m omega squared plus r omega squared. Lahat yan ay root. Then yung phase okay. So, pwede niyo i-check na yung x is actually a solution to the different equations. So, syempre dito kukunin yung first derivative with respect to time and second derivative with respect to time. Okay, and then and when you take the derivative, remember this is derivative with respect to time, not derivative with respect to angular frequency. Okay, so hindi niyo kukunin yung derivative yung a at saka yung phi. Okay, kukunin yung derivative ay yung cosine. Okay, kasi yung cosine ay merong dependence sa time. Okay, now if we plot this function, anong makikita natin? We plot this function at saka yung function na ito, yung okay. Ano ang nangyayari dito? So, depende yan kung saan kayo magsisimula, of course. Yung nasa left is amplitude with respect to frequency, and yung nasa right is phase with respect to frequency. Now, let's say you start at some angular frequency, tapos in-increase nyo yung frequency of oscillation. Okay, pag ginawa nyo yan, ang titignan nyo rito yung arrow. Okay, so susundan nyo yung arrow. Let's say dito kayo nagsimula. Pumili tayo ibang kulay. At diyan kayo nagsimula. So, ang ginawa nyo is in-increase nyo yung frequency. So, pag in-increase nyo yung frequency, susundan nyo lang yung arrow na yan. Okay. Yan yung arrow that describes yung nangyayari sa amplitude as a function of frequency. As you increase the frequency. Now, at this point, okay, hindi nyo susundan na yung, hindi bababa. Dito. Okay? So, same na angular frequency. Okay, so nag-jump siya. Okay, now, if you increase the frequency further, susundan nyo lang din yung arrow, dun siya pupunta. Okay, pero if you begin to decrease the frequency, okay, then from here, susundan yung arrow, susundan niya ulit yung solid line up to this point. Okay, and at that point, responding to omega, to some frequency omega 1, okay, magja-jump siya ulit back. Okay, and if you decrease the frequency further, ganyan yung mangyayari. Okay, so this behavior is called hysteretic na behavior. Okay, so in the same manner, yung phase angle is also dependent on the frequency. And halimbawa dito kayo nag-start sa omega naught and you increase the frequency, ito yung susundin niya. Okay, then at omega 2, akit siya, magja-jump siya from this value of phi to this value of phi. And then, if you increase it further, pupunta siya doon. Now, if you decrease the frequency, dito siya dadaan. Okay, and then at omega 1, babagsak siya. Okay, and then if you decrease it further, babalik siya dito sa, susundan niyo ulit yung solid line. Okay, so it doesn't follow exactly yung path ng amplitude tsaka nung phase angle. Okay, instead, merong dalawang points that corresponds to specific frequencies like omega 1 tsaka omega 2. Okay, na pag na-reach nila yung point na yon, mag-jump siya from one point to the other point. Okay, and that's because in terms of energy, mas efficient sa kanya yung energy. Okay, kasi maintindihan niyo naman ba yung amplitude, bababa yung amplitude pagdating sa omega 2. And from omega 1, mas efficient sa kanya na i-direction niya from this point to this point. Okay, yung amplitude in terms of energy. Okay, now you don't see this type of behavior often, okay, sa mga oscillating systems, but again, if you recall yung physics 101 ninyo dun sa elastic na behavior, yung elastic na behavior is actually hysteretic. Okay, so halimbawa, anong tawag dito? Yung plastic, for example, di ba, pag binibend nyo siya, ini-increase nyo yung tensile force, right? And then pag nirelease nyo siya, hindi magdi-decrease yung tensile force, magdi-decrease yung stress. Okay? Now, for some plastics, nade-deform siya. So, ma-reach niya yung point ng deformation, and then magbabago yung stress point. Okay? So hindi na siya babalik dun sa original niya na point, and instead babalik siya, bababa siya. Tapos pag decrease niya yung tension, mag-jump siya diretso dun sa original na line, yung tawag dito, yung load line yung tawag. Okay? So yun yung parang siguro experience niya so far pagdating sa hysteretic na behavior. Okay? Okay, so yun lang actually yung gusto kong sabihin about that. Okay, and yun lang din yung discuss dun sa book. Okay, it's just for noting na yung klaseng behavior na again is dependent on frequency. You expect na merong hysteretic behavior yung system na yun. Okay, so cyclic siya, okay, pero tawag dito, oscillating siya, pero the amplitude and the phase angle doesn't follow the same path. So ganun. Move to chaos. Tulad sa hysteresis, it's not the first time na naka-encounter kayo na-encounter niyo yung concept ng chaos. Okay? In fact, siguro araw-araw nyung na-experience yan. Tama ba? Okay. So, saan nyo unang na-encounter ang chaos? Sa? 131, di ba? Saan pa? Sa? Anong LE? Anong LE? 101? Oh, sa 'di ba sa 161, sa 131 may mga problems, 'di ba that involve chaos. May iba sa inyo sinolve yung double pendulum. 'Di ba ano pa? Yung iba sa inyo ni sinolve niyo. Meron yung parang itsurang butterfly, 'di ba? Parang yun yung actually ibig sabihin, no? Actually mas maraming na ang tingin ay butterfly yung shape niya. Imbis na heart. Pero okay lang kung ang gusto mong tignan eh. Kung heart yung tingin mo doon. Okay? Hindi, sinasabi ko lang. Okay. To each his own. Okay? Ang tawag dito? Ano equations yung nag-describe ng ganung behavior? Nalala niyo ba? Nagsisimula sa letter L. Lorentz. Diba? Lorentz equation. Iba sa inyo yung sunod. So meron siyang tatlong differential equations, diba? Describing yung behavior ng x, y, z, and then dx dt, dy dt, tsaka dt dt. So, and then you come up with this elaborate na shaping na phase diagram. So, it's not actually the first time na naka-encounter din kayo ng phase diagram. Kasi nakita nyo na sa 131. Pero hindi nyo lang na-interpret. Okay? Okay. So, mukhang nakikita nyo na kung saan papunta to, no? Balik tayo sa 131 days. Okay. So, okay, paano ba natin gagawin to para ma-record din natin yung nangyayari? Okay. Okay, so next meeting, magkakaroon tayo ng quiz. Diba? Tulad ng sinabi ko kanina. Diba? Okay. So, kung wala nang tanong, then see you next week. See you next week. Okay. Buti at nakuha niyo yung ginagawa ko. Ano? So, may Zoom. Okay, and time. Okay. So, hindi nyo nakikita kung ano yung share, no? So, let's see. Okay. Brings back memories ba? Tulad ng kanta niya, no? Adam Levine, memories bring back. Memories bring back the double pendulum. Okay. Nalala niyo itong the double pendulum? Yung iba sa inyo ginawa ito, yung iba hindi. So, meron kayong double pendulum kung merong isang pendulum na nakakonekta pa sa isa pang pendulum. And then, ang gusto yung mangyari is tignan yung behavior nung pendulum na yan. Okay? So, dito, merong actually apat na differential equations. Okay? Tinatry kong i-increase. So, merong apat na differential equations. Okay? Yung first pair of differential equations involve yung tawag dito, angular displacement at angular velocity. And yung second pair involves yung momentum. Okay. Momentum and yung force. Okay, so yung dp dt is its force. Okay, so anong tawag dito? We want to describe from these equations we can describe kung paano nagbe-behave yung pendulum. Okay, and titignan natin by solving these differential equations. So, ang ginamit natin constants of course ay 9.81. Yung length ng unang pendulum is 1, yung length ng pangalawang pendulum is also 1. Yung mass nila ay also sinet lang natin to 1. We can of course change yung mga masses na yan tsaka lengths na yan. Okay? But they wouldn't matter too much. Yung ating initial angle dito, yung initial angle ng unang pendulum is pi over 2. At yung initial angle ng pangalawang pendulum is also pi over 2. So ano yung itsura nung pendulum? Kung parehong theta 1 at saka theta 2 is pi over 2. So saan sila nag-start? Theta 1 is pi over 2. Ayun yung definition ng theta 1. So with respect to the vertical yung ano diba? So pag asa na pi over 2 diyan? Horizontal, right? Right? Okay. And yung theta 2 na pi over 2 is also horizontal. So nakaganyan yung pendulum. Yung starting position. Okay? Okay. And then yung initial na angular velocity is 0. Okay? So parang at that position, binitawan niyo lang yung pendulum. Okay? Para yung initial na ano is 0. And then yung time is from 0 to 20 with a time step of 0.1. We use ODE 45 para i-solve yung problem. Now, to be able to use this, define natin yung y as these para about y1 is theta 1 at saka yung y4 is theta dot. Okay, and then we define these parameters para ma-convert natin sila into Cartesian coordinate system. Okay, and then pinlot natin yung results. Okay. So ito yung result ng angular displacement with respect to time for both theta 1 at saka theta 2. Okay, so yung blue dito yung theta 1 at saka yung tawag dito yung red is yung theta 2. Now for theta 1, medyo straightforward naman yung behavior niya. It's just sinusoidal na ganyan, di ba? But at some point, yung theta 2, okay, yung theta 2 nag-start out siya as also sinusoidal because parang nag-swing lang siya along with the top pendulum. Pero at some point, bigla siyang mag-deviate. Okay? So makikita natin kung paano yung deviation ng behavior. Of course, if you look at this graph, parang ang hirap imaginein kung paano yung displacement. Right? Right? Okay. So kaya kailangan natin anong tawag dito? I-plot. Tawag dito. I-animate. What about yung angular velocities? Okay. Ito, anong nakikita niyo sa angular velocities? So yung omega 1 is for the first pendulum and yung omega 2 is for the second pendulum. And makikita natin na almost periodic din yung omega 1, then yung omega 2 is periodic to some from time t equals 0 to some time, and then from beyond that time, hindi na siya periodic. Okay? Now, ano ang tawag natin dito sa behavior na to after this region? Ang tawag natin sa behavior na yan ay hindi na periodic, kundi chaotic. Di ba yun yung pinag-aaral natin ngayon? Right? Chaotic na behavior. Okay? So yan, chaotic na behavior. A behavior that is unpredictable. Right? So we also draw the phase diagram. Okay, alam niyo kung paano i-draw ang phase diagram, di ba? Yung angular frequency, angular velocity versus yung angular displacement. Okay, at ito yung phase diagram for the first pendulum. Mafi-figure out niyo ba kung saan yung starting position? Saan? Hindi, yan yung end. O yung nakikita niyo dyan is yung final na position. At yan yung t equals 20 seconds. Saan? Dito. Hindi, ito yata yung, hindi, ito yata yung starting position pala. Oh, yan yung starting position, ito yung end. Okay, paano natin alam na yung starting position? Anong angle? Anong angle? Ano yung parameter na nagsabi sa atin ng initial positions? Ano tawag na sa parameters na yun? Initial conditions. Nag-set tayo ng initial conditions, di ba? So, initial condition natin is t equals 0. Ano yung theta 1? Pi over 2. So, tama ba nasa pi over 2 yan? Sorry. Nakalimutan ko sabihin. This is in terms of radians. Dinivide ko to by pi. So, kung nasa siya? Nasa 0.5 siya, di ba? So, it's 1/2 pi. So, yung theta dyan, dinivide ko by pi over 2. Yun yung makikita niya. By pi pala, sorry. Ayan. Yung omega, dinivide ko by pi. Para mas madaling interpret. So, that means, this is 0.2 pi, this is 0.4 pi. So, ito ay 0.5 pi. Okay? And yung initial na angular velocity niya is 0. So, tama, no? Yan yung initial position. Okay, so, and then, of course, mahirap siyang sundan. Okay, kasi nga, ang behavior niya is chaotic. What about yung pendulum 2? Mas chaotic siya. Diba? Saan yung starting position niya? Doon din sa 0.5, diba? So 0.5 somewhere here, tsaka 0. Yung angular velocity. And dito, mas obvious yung chaotic na behavior. And how does it look like? Okay. So, i-times 2 natin. Okay. Ito yung initial na position, di ba? Right? And yun natin initial position. So, tignan nyo. Okay. Sumusunod pa yung red as shown dun sa displacement. Okay. Pero at some point, biglang, after some time, biglang mag-swing out of position yung red. In fact, lulusot na siya sa blue. Diba? Lumusot pero ito lulusot na yan. Ayun, nakita nyo? Lumusot siya sa blue, which is, of course, physically impossible. Right? Right? So, but in any case, this describes chaotic na behavior. Okay? Okay. So that's for the simple pendulum. Okay, ngayon na siguro mas na-appreciate nyo na yung ginawa nyo sa 131. Hindi pa rin. Salamat sa honesty. Okay, now let's consider this. Ito yung equation na kinonsider din natin kanina. Okay, dun sa slide, kung tignan yung notes nyo, tignan yung notes nyo. Ano yung una equation na sinulat nyo? So, parang ganyan itsura, di ba? Parang ganyan itsura. So yan ang sinusolve natin na equation niya. So this also describes pendulum, except na meron kayong driving force dito. Okay, ang driving force is F cosine omega t prime. Okay? Now, the way to solve this, of course, is to break this into tawag dito, two first-order differentials na makikita natin x dot is equal to y. Yan yung unang first-order differential equation. And yung second is y dot is equal to negative c dot cx dot minus. Sinet natin yung c, yung c and yung f are simply constant parameters. By the way, yung constant na yan at saka yung constant na c at saka yung f ay nandoon sa book. Okay? So babalikan natin yung equation natin. Okay, so yung constant na c ay sinet natin to 0.05 and yung angular frequency sinet natin to 0.7. Yung force ay pinapalitan natin in steps of 0.1 from 0.4 to 1.0. And then we solve this using ODE 45. Tapos, ito yung solution. So what we see here is the displacement and the position, sorry, and the velocity. Okay, as a function of time. Okay, so it appears to be periodic. Okay, so given these parameters, yung f is equal to 0.4, periodic yung behavior ng system. Okay. Now, if we take a look at the phase plot, makikita rin natin na periodic siya kasi matulad sa sa mga nakita na examples before, pag periodic siya, parang oval shape lang siya or circular lang. Pero in general, yung behavior niya is still periodic. Okay? Now, we can change yung F. Dito natin papalitan yung F to 0.5, for example, and then run this again. Okay, and then take a look at what it looks like. So, yan. So, changing yung driving force. Okay, and that's because hindi na in sync yung diba? Yung angular frequency at saka yung driving force. Okay, so paano natin anong example yung pwede nating diyan i-tawag dito? I-consider. Siguro ang pinakamalapit na example is yung tao na nasa swing, right? Tapos nag-apply kayo ng force, and then ina-apply niyo yung force at certain frequencies, right? Alam natin pag yung frequency na pag-apply niyo ng force is the same as yung frequency ng pag-swing ng tao, okay? Mag-enjoy yung tao kasi tuloy-tuloy lang. Now, if you change the frequency ng pagtulak nyo, mababawasan yung niya, diba? But also, if you change the force, okay, nagbabago rin yung kanyang tawag dito, yung kanyang amplitude. Paano nagbabago yung amplitude niya? Dito, ginawa natin, nilakasan natin yung force. So, nag-swing siyang ganyan, okay? Tapos nilakasan natin yung force. Dahil nilakasan natin yung force, yung amplitude, tataas. Pero remember, you are using the same force at the same frequency. Pero dahil tumaas siya, yung period changes. Right? So pagdating niya sa baba, okay, nag-apply ka ng force na hindi in sync dun sa pag-approach niya sa'yo. Okay, just because you increase the force. So what will happen is it will develop into this chaotic na behavior. Okay? And if ganyan yung magiging itsura nung ganyan yung magiging itsura nung phase plot. Okay? It doesn't resemble tawag dito, a periodic behavior. Okay? Remember, pag periodic siya, it's circular or elliptical. Okay? Pero ito, walang semblance ng periodicity. And ito ay papasok yung force 1, then you will see na okay, hindi na siya periodic. Okay, so you can try to figure out kung aling values ng F yung magbibigay ng periodicity, okay, by just changing yung values dito. Okay, so yan, hindi rin yan periodic. Okay. Now, if you pag tinignan niyo ito sa book, okay, iba yung results na nakukuha ko dito at saka iba yung results na nakukuha ko sa book. Na meron sa book. Okay? Sa book, may certain values ng F na lilitaw ulit yung periodicity. Yan. Ay, ginawa ko. New share. And then... Okay. Okay, so yan. So dito, makikita nyo na pag F is equal to 0.4, yan, periodic siya, di ba? And then, pagdating sa F is equal to 0.8, tsaka 0.9 is also periodic. Okay. Pero yung F is equal to 0.5, 0.6, 0.7, at tsaka 1, wala siyang periodicity. Ito pwede nyo pang i-consider to siguro na periodic. Okay, ito pwede pa siguro yan, di ba? Pero definitely yung 0.6, 0.7 at saka 0.8 at saka 1 ay hindi na periodic. Okay, so there are specific forces forces na nawawala yung periodicity niya. Okay? Now, bakit hindi ko ma-duplicate? Kasi sa book, hindi ko alam kung ano yung initial condition. Okay? And pag tinignan ko dito sa taas, yung initial condition, it seems, is siguro negative 1. Di ba? Ang, anong tawag dito? Negative 1 ang angular velocity. Ito yung ibig sabihin ito. Pag F is equal to 0.4, yung angular velocity at t equals 0 is maybe negative 1. But it has a negative value in any case. Pero pag ginagawa ko yan, hindi ko nakukuha yung periodic behavior. Kahit na anong ilagay kong value. Maybe ma-figure out ninyo kasi send ko naman sa inyo yung tawag dito, yung files. So maybe ma-figure out nyo kung ano yung initial condition dito. Okay? And if you do, let me know para ma-reconcile natin itong results dito sa Okay? So, any questions so far?
So yung chaotic behavior, naka-base lang siya sa driving force?
Hindi lang. Pati sa angular frequency. But not sa driving force. Hindi lang sa driving force sa angular frequency. Yung simple pendulum na pinakita natin kanina, double pendulum na pinakita natin kanina, driving force to. Meron ang driving papasok. Yung Lorentz equation, wala namang driving force na. Basic example ngayon kung ano yung mga periodic at saka chaotic na. Okay? Any other questions? Let's go back here. Okay. So saan nakuha yung equation kanina na discuss natin? So it was actually obtained from this. Okay, so it's just a simple pendulum. Okay, na ganito yung shape niya. Okay, ito yung vertical line, ito yung angle na theta, and then yung length is L. Okay, and then yung mass nito is okay. How do you solve for the equations of motion? Here, ang tindate niya rito is torque. So nag-sum siya ng torque. Okay, and ang ginamit niyang pivot point is this one. So yan yung pivot. Okay, so when you sum the torques, okay, then you get I alpha, right? You sum all the torques, then is equal to I alpha, or equal to sa moment of inertia times theta double that. Okay, ano yung mga forces na involved dito? Of course, nandiyan yung force na mg sine theta. Okay, if you add the ano tawag dito? If you add a damping force, So meron kang damping force in this direction na B theta dot. Okay, itong damping force ito is proportional to the first power of the angular velocity. Okay, and then you also have, in this particular example, meron siyang driving torque of angular frequency. So meron siyang additional force which is yung driving torque. So dinadrive ito, so may additional force dito. Plus. Okay. So ang driving torque ay in this direction at equal siya sa ND cosine omega D. Okay, so yan ay driving torque. So external force yan. So we have, this will be equal to minus mg L sine theta. Remember, this is torque. Kaya may L dyan. And then minus B theta dot. Yan yung damping force. And then yung driving force na ND cosine omega D. Omega sub D. Okay, and then if you rewrite this, you get theta dot is equal to minus ano ang moment of inertia nito? So ano ang moment of inertia? Ng rod at saka may ano ka sa oh. Naalala niyo ba? So that's ml squared. Okay. So divide natin everything by ml squared. We have negative G over L sine theta minus B over ml squared theta dot plus ND over ml squared cosine omega D. Okay. Okay, let's set omega naught squared equal to G over L. Okay, so, and then I divide everything by omega naught squared. So pag ginawa ko yon, okay. Okay, doon natin nakuha yung x dot. Sorry, yung equation na kino-consider natin kanina. Okay, any questions? Any questions? Wala? Pagod na kayo? Hindi pa kayo pagod. Ayos. Walang sumasagot eh. Okay. So, topic na dito sa lalabas dito ay yung concept function. And titignan natin kung paano yung mag-evolve to chaotic behavior. Yun yung discuss natin sa first step. For now, do